into minus k cross E dot delta H. Okay, so this I can write this, and here we have delta E dot this omega epsilon E， 就这边一样啊 ，delta E 究竟放左边放右边其實沒差，因為 epsilon 是對稱的嘛。You can change the order from the right hand to the left hand because epsilon is a symmetric matrix. Okay, and the minus and the plus here minus. Here minus k dot E， 这一项啊，这一项你用过了，用这一项啊 ，minus k dot delta E cross H is equal to k dot H cross delta E, and this is equal to k cross H, k cross H dot delta E. Okay, so now we have delta E, and we have k cross H. Okay. So according to Maxwell equation, K cross H plus omega epsilon E is equal to 0. And K cross E minus K cross E plus omega mu H is also 0. Okay. So finally we find that two delta K dot E cross H is just the pointing vector. Pointing vector is equal to delta omega times this plus this is the two times the energy density. Okay, so both sides we have 2. We get delta K dot S is equal to U times delta omega. Okay, so delta K dot S over U is equal to delta omega. But according to our definition of energy velocity is nothing but pointing vector divided by the energy density. So this means that delta K dot VE, E means energy, is equal to delta omega. So now we have delta K dot VE is equal to delta omega. However, if we do the variation to omega, this means that we change the K. We change K to see the resultant change of omega. This is the chain rule. And the three factors are just the three components of the gradient omega. And delta k, delta k1, delta kc are just the three components of the delta k vector. So I can write this as del k omega dot delta k. But according to our definition of group velocity, del k omega is nothing but group velocity. So we have the right hand side equal to the group velocity dot delta k, and the left hand side we have delta k dot VE. So we find that VE minus VG dot delta K is equal to 0. However, we know that the delta K is an arbitrary vector. Although it is infinitesimal, but it is also arbitrary vector. So this means that VE is equal to VG. VE is equal to VG. Okay. So what does this result mean? We consider the normal surface. Here is a part of the normal surface. Which means that the omega as function of k. We know that omega is function of k, but if we give a fixed omega and find all the possible k vector, we plot all the possible k vector, we get the so-called normal surface. According to your engineering mathematics, you know one thing, that gradient f vector is perpendicular to f equal to constant surface. 记得这件事吗？不记得。公数里面告诉你说，你现在比如说in engineering mathematical physics mathematics, we know that if we have a function of x, y, z, and I fix the value of x, y, z to 0 or some constant or 0, then this gives us a surface. Now, if I this is the surface of f r equal to constant. Say f0 constant. So if I move from here to here along the surface, we will not change the value of f. Okay? So this means that df equal to 0. The corresponding df becomes 0. However, df is equal to gradient f dot dr. So this means that gradient f is perpendicular to dr. Okay, so the direction of gradient f, the direction of